Okay, as promised, I'm going to make a series of videos to go over the rules of inference. The rules of inference will be from Graham Forbes' Modern Logic book. And so on the back of the cover, we'll have the list of rules. They're defined in the schematic version, so I'll go over real quick how to read the schematics. So first we'll do the rule of AND elimination. So what we have here is, if you look at this letter here, it's just a variable that indicates whatever line number you're on, right? If you have the formula P and Q, of course its dependencies are this weird series of variables. It just says that given this set of dependency numbers, we'll carry it along once we get to K. So K here is just, again, another variable for a line number. So on line J, if you have P and Q, on a subsequent line, K, you may infer P or Q. And then all we have to do is reference the line number J, where we got the original conjunction from, and the rule of AND elimination. For the dependency number, since we've gotten it from line J, the dependency numbers on line K should match those of J. This is why the set of variables on J matches the set of variables on K for the dependency numbers. So that's how you read the schematic definition for the rule of inference. Okay, so let's get an example. Let's do if W, then if T, then D. Therefore, this is the single turn style. It just means that the argument has a proof from the premises to the conclusion. And so our conclusion will be W and T. That is, if W and T, then D. So here we have one premise and a conclusion. So to set up, we go from our premises. We have one, which is W arrow T arrow D. So we list that as premise, right? Then our second step will be to, look at our conclusion. So here we need to make a conditional. So to use the rule of arrow introduction, we have to assume the antecedent to the arrow. So the antecedent is W and T. So we'll assume that, W and T. Here we assume that. And so for every assumption that we make, we have to sort of think ahead and see how we're going to discharge it. And the way we discharge this rule is, this formula is arrow introduction. So once we use this rule, we know that we can discharge this assumption. So I'll make another video later on how to calculate dependency numbers, but for now I'll assume that we sort of already know how to do that. So line 3, here we're going to apply our first rule of AND elimination. So here we have assumed W and T, so this is a conjunction. So from a conjunction, we may draw out each of its conjuncts. So I'm going to use both of them, so I'm going to draw out both of them. So I'm going to derive W, right? So that comes from 2, and we refer to the rule of conjunction elimination. And the dependency number will come from line 2, which is 2. So I'm going to do the same thing for T. So here I'm going to derive T from 2 as well, and it's just another application of the rule. So here I have W and I have T. Once I do so, I can use an additional rule, the rule of arrow elimination, which I'll go over in a subsequent video, to derive T arrow D. Right. So since I have the antecedent, which is on 3, and the full conditional, which is on 1, which is my premise, from 1 and 3, I may derive the consequent with error elimination. So it's dependency numbers for line 5 will come from 1 and 3, which is 1 and 2. Okay, I'm going to stop there and move on to a different rule so that you'll see the application. So just to review, for the rule of conjunction elimination, from a conjunct that you've derived on some line, whatever line that may be, you may just reference that line and apply the rule of conjunction elimination to sort of pull out or infer one of its conjuncts. Here we've inferred both of its conjuncts by 2 applications of the same rule, of course from the same line.